This is AP Calculus AB. We are on self-check 4.2. All right, in number one, we're trying to find the derivative of y. So whenever we have the derivative of y, we need to take the derivative. So this one is a little bit tricky. We haven't done one of these in a while. The derivative of 3x is 3. That's the easy part. The derivative of a negative, we'll just put a negative right there for a placeholder. The derivative of tangent is secant squared. Secant squared of whatever the inside was. The inside is still y. Don't forget your dinner. The derivative of the inner. The derivative of y is a y prime. So I need to multiply by the dinner. And this is going to be equal to the derivative of a constant is 0. So we've taken the derivative. We just need to solve for y prime. Oh, that y prime. There we go. And then we're done. Okay, so I'm going to move the 3 over here by subtracting 3 on each side. So maybe I can show my work. Subtract 3 on both sides. That's going to give me a negative secant squared of y times my y prime still is equal to a negative 3. I need to get rid of the stuff next to my y prime. So I'm going to undo this multiplication by dividing both sides by a negative secant squared of y. Divide this side by a negative secant squared of y. Maybe I'm showing too much work here. And that's going to give me my y prime by itself. And that's going to be equal to, well, a negative divided by a negative is a positive. This is going to be a positive 3 over secant squared of y. Done, right? I mean, we are done, but that's not showing up anywhere. I don't see something with a secant squared in the bottom. I mean, maybe there's a squared in the bottom there. No, you're wrong. So you have to remember another fact. So recall that the definition of secant of some random number is 1 over cosine of that number, which implies that 1 over secant of a number is the same as cosine, unflipped, of that number, which means that our secant squared is going to flip up to the numerator and become a cosine squared. So this is going to be equal to, still 3 in the top, that doesn't move anywhere, times cosine squared of my y. There we go. We flipped the secant squared up and made it a cosine. That's the definition of what's going on here. So I have 3 cosine squared y, and there's option B, 3 cosine squared y. Number 2. All right, we got word problem. Looks like related rate. Here we go. Circle. Radius of the circle is increasing. Increasing is a positive word here by 0.2. So I can say r prime, because it's changing, is equal to a positive 0.2. I'm saying that the rate of the area of the circle is the question. So I'm going to say area prime here is the question. I'll make that an empty box. The instant when the circumference is 20. So the circumference here, not prime, is equal to 20 pi. All right, we've extracted all the information we can from the problem. I'm now going to ignore it for the rest of this problem, and I'm going to try to solve for area prime. Well, I know the area of a circle is equal to pi r squared. And I can take the derivative of the left and derivative of the right, 2 pi r prime, and hopefully I can just fill it in. I mean, if I can just fill in an r and an r prime, I'm done. So let's go ahead and say, okay, area prime then is going to be equal to 2 times pi times r. Ugh, darn it, we don't have an r, but we do have an r prime. This r prime is this r prime, which is 0.2, so times 0.2. All right, well, curses. I need to find that r. Okay, well, look, I've done that one. I haven't used C yet. I haven't used circumference. So what's the formula for circumference? Circumference is 2 times pi times r. And I happen to know that this circumference is 20 pi. Therefore, this circumference is also 20 pi. That's equal to 2 pi r. If I divide both sides by pi, go away. If I divide both sides by 2, that's 10, and 10 is equal to r. And hey, look at that. This r is what I was trying to find, and I now have it. R is 10. So I can come back here and plug in 10, and I know that whenever I multiply by 10, I move the decimal place, so these two multiply to a 2, and 2 times 2 is 4, and I get my area prime is equal to 4 pi. Moving the decimal places looked like it was the hard part because you can get one of those 3 different answers depending on how you move decimal places, but the correct answer here should be C. I can box my work. Did I box my work last time? Ta-da, there it is. All right, you don't have to box your work if it's multiple choice. I just care about the right letter on these. All right, number 3, another related rate problem. What do we have? We have the radius is decreasing. Decreasing is that negative word, so we can say r prime, because it's changing, is a negative 2. So I can say it's equal to a negative 2. What else do we have? The radius is 3. Therefore, just r with no prime is equal to 3. And I'm asked to find what the rate, so it's something prime, of the surface area. So it's surface area prime is equal to box. That's what I'm asked to find. And it gives me some helpful formulas that I'll probably need to do. I mean, if it gives me S and I'm asked to find S prime, I'm probably taking the derivative. Let's go ahead and do that right now. So S prime, when I take the derivative, the 2 comes down in front for powerhouse. This is going to be 8 times pi times r to the power of, okay, it went down to the power of 1, so I just write r. And then don't forget your dinner. r prime. All right, if we fill into this, we're done. Do we have an r? Wait a second, Mr. Sindel, why'd you write a prime, you silly boy? All right, r is equal to 3, done. R prime is equal to, you literally just plug them in. Wow, look at that, that's easy. This is gonna be s prime is equal to 8 times pi times r, which is 3, times r prime, which is -2, and we get our answer. Okay, what do we have here? 3 times 2 is 6, don't forget the negative, and 6 times 8 is 48, so I get 48 pi with a -48 pi, and that's option C for S prime. Very nice. All right, last problem for this self-check, number 4. We got another triangle problem. Let's go ahead and make a diagram. All right, diagram, right triangle, go, ta-da. Right angle goes right there. Extracting information from the text. It's sliding down the wall, which is usually the case, so let me go ahead and draw an arrow down so I don't forget that. And the rate is 3. All right, we need some variables. I'm just going to go with x, y, and z again. I'll call you x, and therefore I'll need an x prime. I'll call you y, and therefore y prime, and z prime. I did those backwards. I don't feel comfortable like that. I want to go like this. Okay, there we go. I need to find all 6 of these, 5 to begin with, and then I'll solve for the last one, right? So I know that there's a 25-foot ladder, therefore this hypotenuse is 25. I also see that it's sliding down at a rate means prime, at 3. So if it's going down, I'm going to say -3 here. I also know that the top is 7 feet from the ground, so therefore this distance here is 7, therefore this x is 7. I also know nothing else. Lovely. All right. I'm asked to find the rate of change of the distance between the bottom of the ladder and the wall. So I'm asked to find u. Let's make you a box, y prime. And I'm missing some information. So I'm missing u and u. Well, this one is kind of interesting because you have to think about the context of the problem. Is the ladder changing size? I mean, it could be, but let's assume that it's not. Because usually ladders for simple problems are just basic ladders that are just one piece and they slide up and down, but they don't change its size. Therefore, z prime will be 0. And to find this y, we need to use Pythagorean theorem. So let's go ahead and draw another diagram to show you what I'm talking about. For a right triangle, if I have a 7, I'll call this one y for now, and 25, I can use the Pythagorean theorem to find lengths of a right triangle. Setting up Pythagorean theorem, I'm going to say leg squared plus leg squared is equal to hypotenuse squared. And then I'm going to do some math. 49 plus y squared is equal to 625. Subtract 49, y squared is equal to, what is that going to be, 576, right? 576, yeah. And then if I take the square root of that, I think that's 24. Correct me if I'm wrong. Plus or minus 24, but it doesn't make sense for it to be minus. So I know y is equal to 24. Let's fill that in up here. Now I have all 5 variables except for the one that I'm trying to solve for. Let's plug this into our formula. Our Pythagorean theorem derivative is going to be x prime plus y prime is equal to z prime. All right, x is 7 times x prime, which is -3, plus y, which is 24, times y prime, which we don't know, which we're solving for, is equal to 25 times 0. All right, well, that right-hand side is pretty easy. The left-hand side is a -21 plus 24 y prime. Add 21 to both sides to make sure that 24 y prime is by itself with a positive 21 on the right-hand side. Divide both sides by 24, and y prime is equal to a 21 over 24. That should be the answer. I'm not seeing that answer. I mean, it was close. Divide the top and bottom by 3. Silly, Mr. Sindel. Okay, divide top and bottom by 3. If I do that, I get a 7 over 8. And 7 over 8. Ooh, that's a problem. I see 2 7 over 8s. Okay, I have to be careful here. I have this arrow saying it's going down, which means I should be going away. I'm going to consider that a positive rate. A negative rate, I would consider like going towards the wall. It's kind of interpretive, though, isn't it? The rate of change of the distance between the bottom of the ladder and the wall. Well, the distance here is increasing. Therefore, this should be an increasing amount, a positive amount. Therefore, the correct answer here is D. All right. That does conclude Self-Check 4.2. There's the back page. There's the front page. Thanks for watching.